When we talked about the differences between substances and mixtures, the definition of a mixture was two or more substances that have been physically combined, and the definition of a compound was two or more elements that have been chemically combined. Well, along those same lines, we should talk about physical versus chemical changes, okay? So, a physical change is basically a change that a substance experiences, but it still stays the same substance, okay? That's really the main defining feature of a physical change, is that the substance undergoing the change maintains its identity through that entire change. And examples of this would be phase changes. So, for example, melting, freezing, etc., melting, freezing, those types of changes, evaporating, boiling, condensing. Those are phase changes because the same substance is just changing from, let's say it's an ice cube. If it's an ice cube, formula-wise, it's H2O. Okay, the substance in the ice cube is H2O. But when that ice cube melts, it's still H2O, even though it's a liquid. So there's been no change in substance. The other thing that is a physical process, which we discussed the other day with homogeneous mixtures, is the solution process, okay? And so just like a little demonstration here is, if I have a glass of water, and I did this, these pictures are mine from my kitchen, so I can just show you. I have a glass of water, which I'm just adding a teaspoon of salt to. So you can see in the second picture, I'm slowly pouring the salt into the water, and then I'm stirring it in the third picture to make a solution. Okay, inside that solution, there would still be water molecules, okay, and then there would be sodium ions and chloride ions in that solution, okay, because when ionic compounds go into solution, they dissociate. And what dissociate means is they break up into the ions. So instead of all your salt staying together, and this is why you don't see a big huge clump of salt at the bottom of the container, because once I stir it, I've made a solution and I've essentially separated the sodium ions and the chloride ions from each other, and they are so well dispersed throughout the water molecules that they stay dispersed and they stay in solution, which we will talk about in much more depth later on in the school year. But that is a physical process because all of the substances are maintaining their identity. There are no new substances being formed. It's just that they are now combined in a container, okay? Whereas a chemical change, the main feature of a chemical change is that a new substance is made. And that new substance has new properties. And that means bonds have been broken somewhere. So there have been bonds that were together. There were atoms that were bonded together. And throughout that process, some of those bonds got broken so that new bonds could be made, okay? And the example that I would show you here, which again is just something very simple that I did at home, is frying an egg, okay? When you crack an egg open, which is in this first picture here, the egg white appears clear, okay? And and the yolk is kind of like an orangey color. So then when you expose it to heat, what happens is a chemical reaction starts to take place in that egg. And the evidence of that chemical reaction is the fact that the egg white goes from clear to white, and it goes from a liquid to a solid. Okay, same thing with the egg yolk. In fact, after I took these pictures, I cooked my egg for longer because I don't like runny egg yolks. You can decide when you order fried eggs. Do you want them over easy, which means like a pretty runny egg yolk? Do you want them over medium, where it means like they're cooked on the outside but a little bit runny on the inside? Or do you want them over hard, which is where the egg yolk is cooked all the way through? Those color changes there and the difference in texture, like the runny yolk versus the solid yolk, is a chemical change because, first of all, you have a slightly different color than you had before. Secondly, you have a new feature that you have. And keep in mind, and you might be thinking, well, wait a second, like, didn't you say changing phases, like solid to liquid, would be a physical change? Yes, however, keep in mind that like when a liquid changes to a solid, as in the case of like water freezing into ice, that's typically because heat has been removed. Okay, so the substance has gotten colder, and that's why it freezes into ice, because the molecules are getting closer together. But in the case of an egg, we're exposing our substances to heat, and those liquid substances are now solidifying in the presence of heat, which is not that's not what you would expect in a phase change. In a phase change, if you expose a liquid substance to heat, it should turn to a gas. It shouldn't turn to a solid. So the fact that we're exposing the egg to heat and the yolk and the white are turning into solids, that suggests a chemical change, because that's not explained by like the freezing or vaporizing process. Okay. So a chemical change is when a new substance is made, and that new substance you can tell because there's been some sort of property change. Okay. All right. Then the last thing I want to just show you about this is how to look at the concept of physical and chemical changes, like at a molecular level. Okay, so we're going to look at, the question actually says which one of these represents a chemical change, but I want to look at both diagrams. So on the left-hand side of the arrow, diagrams A and B are identical. Okay, you have 6 molecules in both containers towards the bottom of the container. They're all grouped together, okay, which suggests that they're either a solid or a liquid. Now, you need to look at the containers on the right, okay, and you need to ask yourself, what is the difference between the container on the right and the container on the left in each case? So if we look at A, okay, take a second and think, like, how does the container on the right in part A seem different than the container on the left? Okay. To me, it looks like the molecules are more spread out. Okay. Instead of being clumped at the bottom of the container, they seem to be everywhere in the container. However, the substances themselves look the same. Okay. Like we still have 2 red atoms bonded to 2 white atoms, which is what we had over here, right? We have 6 of them on the left, we have 6 of them on the right. So the substance itself looks identical, just its location in the container looks different. That suggests a phase change, okay? Based on what I know, I would guess that the substance on the left is a liquid, and the substance on the right is a gas, because we know that gas is spread out throughout the container. Okay, and so same substance but different location. If you look at example B, on the other hand, that picture looks very, very different. Okay, so instead of having 6 molecules on the left, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on the right. And not only that, but they're different. So now we have the red atoms bonded to each other, and we have the white atoms bonded to each other, but the red and the white are separate from each other now. Okay? That suggests that new substances have been made because these molecules over here don't look like these molecules over here. They look different. So that's a new substance. So B is your chemical change, while A is your physical change. And that's how it would look on the molecular level.